Hello, everyone. Thank you so much for joining us again for another engaging Data Bites session. We're having loads of great conversations at the moment with some of our existing clients, as well as many new prospects around projects to replace or upgrade existing legacy systems. There is, however, a reluctance to move ahead in most cases as businesses fear what is essentially open heart surgery on their tech stack. So we wanted to address this. We know that ripping out legacy systems isn't always the answer, but actually supplementing them with automation technology can help transform and modernize a company's data. We thought it best to showcase this with a solution which is a real life example. So we've invited our partners at WhereScape back to talk us through a case study that does just that. So I've got James and Pat from WhereScape with me, and they're going to cover off an overview of WhereScape and an introduction to this case study, as well as showcase the solution that was provided and all of the benefits. But before I hand you over, please stick any questions you have at any point in the Q&A, and we'll hopefully have time to go through those at the end. And also, we are recording this video, so anybody that's signed up will share a recording. So if you need to drop off for any reason, you've got nothing to worry about. I think it's best we dive straight into this. We're going to be starting with James. So James, how are you doing?
Hi, Chris. Yes, thank you. It's been good. We're looking forward to sharing this case study and showing exactly how WhereScape can modernize your legacy data warehouses. So thank you again, Chris. So thank you for everyone that's joined us today. You're here to learn about how US Lumber builds a modern data warehouse with WhereScape as its foundation. What I would do first is cover off exactly what WhereScape does and with our over 1,200 customers worldwide. We've got over 20 years worth of experience helping IT teams fast track projects and deliver more through data infrastructure automation. We do this using a drag and drop graphic user interface, which automatically generates pages and pages of code for you, which means that it not only helps the build, but also the maintenance of your data warehouse solution. And what we find is that by automating these processes and these long-winded steps, you can produce over 8 times the development speed as you would when you're hand coding. And what this means is that you can deliver faster, happier end users as they're receiving reports and they're receiving a business-ready solution as quickly as possible. And it's done with a reduced cost with limited risk as well, as none of it is outsourced and you can keep all of it in-house and everyone is doing the same drag and drops as well, producing that same code. It also provides that greater consistency and supportability going forward. We're a platform agnostic tool, so it's easy to evolve and expand onto new platforms in the future. So if you're using something like SQL Server now, and a good example of that modernization is that the worry of moving on to something new and having to start again from scratch. But with WhereScape, you can lift that metadata, place it into that new platform as well, and start to regenerate that code on your new platform. A whole process is also fully documented and compliant as well. But you're here to learn about how exactly US Lumber have done this using WhereScape. So just a quick overview of US Lumber. They are a specialty construction products distributor headquartered in Duluth, Atlanta, Georgia, and employs over 2,000 people. It has branches on both coasts of the United States and across every province of Canada as well. So what was the challenge US Lumber was facing? The company has been in acquisition mode for the past 8 years and was enjoying a period of ambitious growth. They had increased from 7 distribution centers to over 30 in just a few years. During this time, the team of 200 grew to over 3,000 people. This prosperity meant much work for the data team of 3, led by US Lumber's BI manager, Mark Paulier. The workload this presented to his 2 direct reports on the data team and 3 other consultants available to him was beginning to overwhelm them, and it prevented them from working efficiently and keeping pace with the growth of the business. It reached a point in which they required a new data warehouse with a new modeling style as well. After much thought, they decided that data vault modeling was the route for them. Its agility stood out in particular, considering a number of disparate data sources his team must assimilate to do its job effectively. However, the complexity of data meant that they very quickly realized that data automation was necessary for their project to be successful. They soon found WhereScape online just from searching, along with another couple of tools, but they decided WhereScape was the superior choice after watching just a short online video as well. But don't take my word for it. Mark Paulier says that WhereScape has an excellent solution for handling data vault complexity and making it possible for our team, which was at the time just 2 people on the data warehouse. So we could never have done it manually. WhereScape provided the ability to get a data vault together into a business vault and out to the data marts. The only other option would have been to get 3 other developers to work on it non-stop. We have found that using data vault and developing using data vault can be extremely tricky without the use of automation. So how did WhereScape solve this problem? The chief reason they invested in the tool was to integrate all of their business systems together. This first meant modernizing and building a new temporary data warehouse to bolt onto the existing one. This pulled data into supplementary tables, which assimilated data from US Lumber's various source systems much faster. And that process was completed very quickly and enabled acquisition to happen faster and smoother. The long-term view going forward, though, was to replace the legacy data warehouse with one that will sustain the growth of the business for years. And as Chris mentioned earlier, that worry about that open heart surgery when it comes to moving onto a new system can be very easily done using WhereScape, where you can build out exactly what you want to on your legacy data warehouse. And when you are ready, you can then take that data and build something new rapidly and quickly so the business does not slow down. But for them, the real game changer was 3D. It was WhereScape 3D, the modeling tool that I was amazed with, Mark said. It was a good tool when I first saw it in 2018, and it's become a lot better since then. We used it a lot at the start of the project. 3D gave us an excellent way to read over the entire database, get the stats, and to load tables in through the staging area and into the raw vault. It was amazing to me how it could do all of that with nothing more than a GUI and no hand coding. At this point, what I would do is I've talked plenty about exactly what US Lumber was going to do and what they saw from that. But it might be best if we are able to show you a little bit of that. So what I would do at this point is pass over to my colleague Pat, who he can show you a little bit more of the tool and exactly how they moved forward using Data Vault.
Thanks, James. So I'm going to start from this diagram, which gives us an overview of all the different sort of industry standard approaches you can take to designing a data warehouse. So we have our sources on the left, we have our visualization tools, so our dashboarding and reporting tools on the right, and basically WhereScape can manage the whole bit in between. So we can extract data from your different sources, whatever they happen to be, land them on your data warehouse platform, whatever that happens to be. So we support lots of different target platforms. And then you can design out, take whatever design approach you choose, whether that's an ODS, which is a one-to-one copy of a source system, optionally with type 2 change history. Data Vault, which we'll be looking at today, which is that same data split out into hubs and links and satellites, which is taking your standard normalization rules, applying those to your data warehouse. And then typically, sometimes standalone, usually on top of some sort of foundation, there's a presentation layer, which is where you are taking data that has been conformed. So you're comparing like with like, apples with apples, oranges with oranges. And the data is in a format that's easy for your visualization tools to consume. And the industry standard for that is some take on a Kimball-style star schema with fact entities that contain things we measure and attributes describing those measures grouped by subject into dimensions. As you're designing the different entities in your data warehouse and the data flows required to populate them, we capture metadata. We use that metadata for lots of purposes. The first is to generate the DDL to create or alter these different entities. The next is to generate the native code required to populate them. So that's basically running set-based operations, updates, inserts, mergers to move the data through our different models. We also use the metadata to generate the documentation. So that's pages of documentation, but it's also lineage. So saying I have a data item over here, where did it come from, what happened to it on the way? Or I have a data item over here, where's it referenced in my data warehouse architecture? Next thing is the scheduler, so the orchestration. We can also generate jobs. You can build them manually, but we can actually generate them for you. We also capture all of the logging information in our metadata. Our metadata is just tables on a database, so it's entirely open. You can build reports and dashboards on top of that. Last concept is retrofit, which is something that we used in this particular example, which allows us to basically integrate with existing infrastructure. So we can use retrofit to discover what has already been built. We don't take over management of that, but we know what's there, and that allows us to quickly build out on top of it. So in this case study, what they did was they had an existing data warehouse. They used retrofit to pull the data in. They used that as the base for their initial data vault, and then they enhanced that with their new sources. So that's what I'm going to talk about a little bit today. I'm going to show you the process, the basic process for Data Vault, how we do that. We can do that in this builder tool that we're currently looking at, which you sort of do things one entity at a time. And that's fine. Lots of different tools do it that way. However, what our customers find is it's much quicker to use our design-driven approach because we can do things in bulk. So to do that, we use WhereScape 3D. So WhereScape 3D is our design tool. It has two use cases. One is around understanding source systems, and the other is around designing or generating our data warehouse. So in the case study, what they were talking about was basically taking a connection to a source system. A connection up here, and discovering that source system. So what that essentially does, it goes away and it reads the metadata for that in that underlying system. So if it's a relational system, it'd be reading the information schema to give us information about all of the entities and attributes within the source. So here, if we go to one of these entities, we can see entity level information, including descriptions we pull back from the database. There's attribute level information, things like data types and again, descriptions, information about indexing on this source, foreign key constraints, which are what are giving me these relationships. If we didn't have those foreign key relationships or these primary keys identified, so for example, if the source was file-based, where we don't have any of that sort of rich metadata, we have some tools which will help you to generate some custom rules to suggest what those things might be. Having gone through that exercise, you have a pretty good understanding of what's available to you. So in the case of our case study, they would have been pointing this at their existing data warehouse, or the parts of the data warehouse that they wanted to pull into their data vault. From there, what you can do is start designing your data vault. So best practice for that is, at this point, we could have a button down here which would say, generate me a data vault. The problem with that is that it would make some very rash, or would by necessity make some very rash assumptions. For example, it would be maybe using, wherever it sees a primary key in a table, it would be using that as the business key in the data vault. And spoiler alert, a surrogate key in a source system is generally not the best candidate for a business key. Basically, when you do your course with Dan Linstead or Michael, they spend the first day or so talking about what are the best candidates for business keys, which is basically something that's common to lots of source systems. And then also about how you best want to capture your data in your data vault. So how you want to split things across satellites. They talk about data volatility, so how often the data changes. That's what we use in our demos, but you can have lots of different ways of splitting that data. They talk about capturing the information about how you want to design your data vault in a tool like Excel. We say instead of capturing that information in Excel, we capture in what we call a data vault design. So data vault design is sort of like a logical model, except it's got some physical concepts. So for here, for example, we might have an entity for customer, and we might design all of the attributes that we think we're going to have associated with customer, give them data types. And then what we can do is we can say where they're sourced from in a particular source system. So this, in the case of today's example, that would have been the existing data warehouse. But then when they got in new sources, when they bought new companies, they would basically be going in here and saying they want to add, their new source system, having discovered that source system, and they go into the sources here and find, the appropriate entity or entities, because it could be more than one entity with customer data. Where the column names match, this will map. Where they don't match, you can use drag and drop. You don't have to populate all the columns. Obviously, the business key, you do need to populate, but all the other columns are optional. So that's how you'd extend this model across multiple source systems, and how easy it is to extend that across multiple source systems. Having done that mapping task, what you do is you click on the button here to generate the data vault. That runs a set of what we call model conversion rules. And those model conversion rules, there's a whole bunch of these that come out the box. Basically, our engineering team worked with Dan Linstead to ensure that these generated a Data Vault 2.0 compliant data vault. But if you wanted to customize the data vault that was generated, you can add your own rules. You can customize you can take copies of the built-in rules and customize them to generate the data vault in exactly the way you want. When you click that button, it runs those rules and it actually generates your raw vault model. So here, if we look at this customer hub, what we can see is the customer hub in this particular design with a single source system. This customer hub has two satellites. Obviously, if there were more source systems, these satellites would by default be split out per source system. So we'd have one set of satellites for north wind and satellites for south wind. Now we can see that this customer hub is related to this link, which is linking order, customer, and employee. So if we go to that, we can see those three hubs being linked and a transactional satellite here. All of those raw vault entities, the definitions of all those raw vault entities have been defined here for us. So the workflow basically is that you tag a few entities, you generate the data vault, the raw vault, see how that looks. If you don't like it, you can go back here, change the tags, regenerate the data vault, and you can go through that iterative process as many times as you like until you get a data vault that you would like to actually build. You then basically click this button. This button has been configured, and what this does is it runs some more model conversion rules to generate definitions for some staging entities. It then takes all of that metadata, it tags it with some information about our target environment. So in the case of today's customer, it was SQL Server, and they then takes that metadata, pushes it through our standard deployment process. That process creates or alters the entities on the database. So on SQL Server, creates all of these entities for us, and it generates the code required to populate those entities. So all we have to do at this point is to generate a job. So we build a job. Now this takes us to our scheduler. I won't go into detail with what that does. That can generate a job that looks something like this. Sorry, this one here, that will populate our data vault. So just talk through what this does quickly. The load tables, the staging entities that follow tables. This is where we land the data that we've extracted from the source system. You can apply delta handling here. If you don't, then the code will handle it later anyway. So if you have to do full loads, we then have some staging entities. The staging entities are where we do all of our hashing and joining if we need to join to get to business keys, for example. These, by default, these entities are materialized. The reason for that is hashing is an expensive operation, particularly if you're on a cloud platform. When we say expensive operation, that does literally mean dollars and cents. So if we materialize these results, it allows us to potentially populate multiple entities in our raw vault in parallel from the same staging entity. Having done that, what we get is we get all of our entities populated. So we get a hub. We look at this hub. So our hubs contain the column or columns that make up the business key and the hash of those values, plus some metadata. Links. So this is linking category and products. We have the hashes of the business keys from the hub for category and product and the hash of those values for the link, and some metadata. Satellites. What the satellites contain is the hash of the business key from the hub, all of the attributes that we tagged as belonging in this low rate of change satellite, plus the hash of those attribute values. That change hash, that is used to identify changes. So if the values of any of these attributes have changed in the source systems, what we do in our staging is we hash the new row, we compare these hash values. If they're different for that business key, we insert a new row because the satellites contain type 2 change history. So they contain a new row every time a value changes in the source. However, Data Vault 2.0 is insert only. So what we get is a start date, so the valid from. What we don't get is a valid to and a current record flag. Yeah. So to make these satellites easier to work with, we go back to our design tool. We click on this button here to generate a business vault. That again runs a set of rules, and that generates a basic business vault. And our basic business vault has two layers of views over these satellites. So those views make these satellites easier to work with. So if you look here, we have customer low rate of change, and we have a customer low rate of change current and a customer low rate of change history. So what the current row view does is it has a subquery which basically returns the current row from the change history. So the row that reflects the data as it stands in the source system. And we can use these views for things like type 1 dimensions in our presentation layer. What the history view does is it returns all of the data, so all of the change history, but it has some transformations in it which provide our end date and our current record flag. So we have the valid from, the valid to, and the current record flag, and we can use those views for things like slowly changing dimensions. Having deployed, again, we just click the button to deploy these entities into our builder tool to create these views. We can then start thinking about our presentation layer. In Data Vault 2.0, the presentation, everything over the data vault is virtualized, so we're using views. So we build these views manually. We basically browse our data warehouse. It shows us contents of our data warehouse. And then what we do is we use drag and drop to create these different views. So type 1 view, we take from the hub, we take the business key, so the business key and the hash of the business key, and then from the current record satellites, the views over the satellites, so these current record views down here, we can drag in the different attributes that related to customer. We then join these together using this little wizard. You always start from the hub because that contains all of the business keys. The satellites may not. So start from the hub, you join on the hash of business key, select a left outer join so we don't exclude any rows, and do that for each of your satellites. And then this tool will generate that ANSI standard left outer join syntax. And because we have those views that are doing the hard work working out which is the current row, that is actually all we need for a type 1 dimension. If you wanted to, you can customize this. You can put in you can use any syntax that your platform supports. So I'm showing you in Postgres today, I think. And it's basically, you can use anything that comes after the from in a select statement. That creates a type, that will create basically a type 1 dimension. Type 2 dimensions, you can create them in very much the same way, except you use the history views. You can use current views if you want to treat some attributes as type 1. And the way these work is because the joins are more complex, we actually have a template that does that all for you. So basically, I just tell it to create, and it creates this template which looks at the metadata, sees at which history satellites we're referencing, unions the history from those satellites, derives the new overall end dates and current record flags, selects all of our columns. If we had transformations, it would apply those there, and then it generates the joins. All the joins are required to pull this together, and what that gives us is a type 2 dimension with our start date, end date, and current record flag. Fact entities, you can, as I've done here, you can create those from links and transactional satellites. They work very much the same way as a type 1 dimension. Typically, you do that, and if you then encountered performance issues, you might decide to add in pits and bridges, which are basically entities within the business vault, which are used for adding in calculations in the case of bridges, or materializing joins in the case of pits. And basically, it can be used to address performance issues. And we have some wizards which will let you walk through creating pits and bridges. They will generate the definitions of those entities. So that's a bridge, and there's a pit. Again, you can just deploy those to red. They are created in our business vault here. A bridge can contain everything you need for a fact entity. So you could just create a view over here, maybe exclude the business keys, but that essentially can have everything in it that you require for a fact entity. So here we have the hashes of the business keys that we would use to join to our virtualized dimensions. And over here we have our various measures that we brought from transactional satellites. So that can create fact entity. Pit tables, point in time tables, we can use those for things that work in a similar way to a slowly changing dimension. The granularity is the snapshot date, that's the only difference. To create those, we take the business key, the hash of the business key from the pit. We join directly to the satellite, so we don't use the views. We can optionally add in some transformations here, which will derive from that snapshot date, start date, end date, and current record flags. And then to join this together, you start from the pit, you join directly to the different satellites, you join on the hash of the business key, and in the pit, we have a start date column for each satellite. So we join on this specific start date column for each satellite. Again, this wizard will generate that join syntax, and that gives us something that we can treat like a slowly changing dimension, although the granularity is actually not the same. It's not the change history. It's actually however often the point in time table has been updated. So basically, I've raced through that because of time. But what we've done there is we basically pointed our design tool at a source system, which gave us information about that source system. We can document that. This shows all the documentation. We can look at profiling metrics for that. We can also track changes on that. So this is a way of tracking changes to the source system. We then designed our data vault. So we added some metadata to a data vault design, generated our raw vault. Then we deployed that, which generated some staging entities, pushed that data through our design tool, built everything on our data warehouse platform, generated all the code. We talked about generating a job to populate that data vault. We then talked through what we get in the raw vault, and then how we build out a presentation layer on top of that, virtualized, as that's best practice for Data Vault 2.0. And then we talked about how we can add in some additional entities to address performance and how they can be used in the presentation layer. That's basically the full end-to-end, very, very rapidly, of our Data Vault story. James, back to you.
Perfect. Thank you, Pat. So using what Pat has just showed you, how did US Lumber end up getting their results from using this methodology? Previously, it was taking over 3 months to get data from newly acquired companies into the data warehouse. Now it takes just 45 days, which is a 50% reduction in what they were doing previously. Due to this reduction of time and effort into the acquisitions, they were able to focus their attentions on their modernization project, which is now complete. Because of automation, US Lumber has had more time to get concepts right and collaborate with the business side, mainly due to how easy it is to drop everything that doesn't work and rebuild it in WhereScape. With WhereScape, however, it is a lot more objective and intuitive. WhereScape provides you with a very visual representation of the flow, and you can just drill down into the particular lineages to find out what is going wrong. It's just faster to debug and to fix as well. US Lumber have now developed a methodology which is more agile than ever. By using WhereScape's out-of-the-box templates to build their own solutions, they are saving themselves months and months of work, which allows them more time to collaborate with the business side and reinvest that time and effort that has been saved. As you can see from the quote down below from David Livingston, as you can see, the day-to-day working lives of the US Lumber team has been revolutionized using automation forever. So that's all I have today. Chris, I'll pass back to you. Have we got any questions at all today?
Brilliant. Thank you, James. I think that comprehensively answers the challenge we put out around supplementing legacy systems. And thank you, Pat, for a great demo. It's great to see another overview. We do have one question come in from Craig, who wants to know if he's on-prem and thinking about moving to the cloud, does WhereScape cater for both?
Yeah, I'll pick that up. Chris, thanks. Yes, basically our infrastructure can work with cloud. We can be entirely cloud native. We can be entirely on premise. We can have parts of your infrastructure on premise, parts of it in the cloud. It's all entirely flexible. If you're deciding to move from on premise to the cloud, we can help you with that journey as well. So, for example, SQL Server, if you wanted to move to Azure SQL, you basically use the migration tool that Microsoft provides to move your Azure SQL database up into cloud. And then it can just be as simple as changing the ODBC DSNs to point to that version of the database and then restart the scheduler. Everything should just work.
Perfect. Well, I think that answers that question. Thank you, Pat. Big thank you, Pat, and big thank you, James, for joining us and going through that. If anyone has any additional questions come through, please do not hesitate to reach out to either ourselves or the team at WhereScape. Thanks again for joining us. Keep an eye out for our next session. I'll leave you all to enjoy the rest of your day. Thanks, everyone.
Thank you.